Two measuring devices will allow us to get two pieces of data from today's experiment. Data is the actual information that comes from our instruments. What comes from the graduate cylinder is a volume. What comes from the balance over here is mass. So if you look at your formula, density is mass over volume, and you look on the board, density is mass over volume. You will have to supply those two numbers. So first we want to start now and fill our graduate cylinders. Now, before all of you just got here, in front of you we have a beaker that should be half filled with water. Check right now to make sure everything is in front of you. And then after that, you're going to take your pipettes out for now. Squeeze the air from your pipettes. Squeeze all the liquid out. Squeeze the liquid out of your pipettes. And take them out of your beaker. And that's right. And at this time, I want you to go and stand up and put your cylinders in front of you. Put your cylinder in front. Push your chairs all the way back. Don't do anything. Follow instructions. Good. Push your chairs back. Because in the lab right now, you're going to be up and working. Now, at this time, that's fine. That's perfect. Perfect. At this time, using your beaker, the way I showed you, and for those of you who just got here, we're going to just show you very quickly when you're ready to fill the graduate cylinder. One of you students that already heard me say this, how should I pour into this beaker? Yes, sir.
You should tip this.
No, you don't tip the cylinder, you tip the what? The beaker. So, and he says tip it. Well, you can tilt, not tip. Okay, you go down the sides, but you go down the side. And you can actually tilt both, it's okay. But why are we doing it this way? Why are we tilting it? Yes, sir. If I just pour it in here like that, what's going to happen? Not just spill, but what am I introducing? What am I bringing in? A lot of what? Bubbles. Do we need air bubbles? Why? One at a time. Right here. Right here. I'm sorry, I didn't give her a chance. Why don't we want bubbles? You won't want it good. What's inside a bubble?
Air.
Air. And does air take up mass? So it has space, right? And inside of this, our volume would be perfectly accurate. So at this time, let's put our two hands up again and practice one more time because you're getting ready to do it. Why am I doing this? I'm what? Removing what? Air bubbles. If they're stubborn, we'll just turn it over slow. But you have to really be good at that one. Okay? I think you'll be fine. Now, at this time, from your beaker, slowly pour, tilt. You may tilt your cylinder. That'll be fine. You may tilt your beaker.
What's the volume?
I think it would be better for you to hold it. She help you with the cylinder. What is the amount you're looking for? Do y'all remember? We're going to 250. Excellent. Do not go to the top. Do not go to the top. So go about 240. Give me about 245. About 245. If you pour, that's perfect. Let me see. Oh my gosh. Oh my gosh, you won't believe this. He poured a perfect 250, including the meniscus. Give me some of that. Yes. Okay, I'm going to mess yours up.
Oh, you gonna mess it up?
I have to because he's got to practice the pipette. Look at this. Okay, well, I don't have to walk around and show y'all mine. Look at the students. He actually needs maybe one little bitty drop. But that was pretty good. Now, I don't want you to pour to the top because I want you to practice this. But I'm getting ready to come around. Now, remove all air bubbles from the line, from your cylinders. Remove all your air bubbles. Remove your bubbles. Remove your bubbles. Remove the air bubbles. But first, you got to get it to hurt. It is going to hurt. But really, it should have, oh, you mean you should pour. I know what you mean. Okay, let me see, ladies. Now, it should be below 250. Almost. Very good, girls. Very good. Let me check yours. So, now, I don't want it to be perfect yet. I'm going to show you how to make it perfect. All right, pick up your pipettes. Okay, pick up your pipettes. Excellent. That's yours. I'm going to put this. Okay, good. Now, what I want you to do now, after after you get it close, just get it close. It doesn't have to be perfect. Get it close. We're gonna show you how to make it perfect. Now, why does it have? What's the word that the scientists use for perfect in the lab? It begins with an A.
Accurate?
Accurate. Excellent. Accurate. You're gonna get a molar bug for that. And a molar bug. Molar bugs are like money in the bank. Things will give you when you do a good job. Now watch this. I'm going to fill my pipette with water. Are you all watching me? Are you watching? And I'm going to make my meniscus perfect. So I'm going to drop, 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 and I'm going to bring this up to eye level. And when I'm doing that, I look eyes on the board. I have to make sure the bottom of the curve sits on top of 250. A perfect, accurate meniscus is when the curve sits on top of the 250. So at this time, you're going to take it to eye level, and the best thing to do is to sit in your seat. Get in your seat and pull it up close. Not on your knees. Get back in the chair. You like that, huh? Okay, I'm going to get in the chair as well. And I'm going to show you. I'm going to come around and make sure this barber's going to take, we're going to walk around. Now, pipettes should be filled, and you're going to come to eye level. And as you release, make sure that you're putting that meniscus right on top. We need a perfect 250. Okay? Feel it, feel it. These are skills that you guys are learning, and skills that will be with you for the rest of your life. Drop, 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 drop. Okay, I'm coming around and see how you guys are doing. Now, before we go any further, make sure that you know what you're looking for. What are we looking for right now? I know that, 250, but what about it? What are we looking for? We want the bottom of the curve to sit on the measuring line, okay? And I just want all of y'all to peek up here right quick. Just look up here, ladies, gentlemen, students. Give me one eye up here. You see this green curve? This is called the meniscus. Let me say meniscus. Meniscus. The bottom of that meniscus must sit perfectly like this. Look, it must be on top of the line. And I need to see perfect meniscus right now. Yes. You can do this. You guys are great. Uh-oh, pipette in. Well, things happen. We just start all over. That's okay. That's okay. I'll get you another pipette. What you got? Okay, now, little lady, what she's doing, she's dropping these drops in here to make sure that it comes on top. You want to drop some of them in? Why not?
She know how to do it too.
Okay.
She already knows.
Can't you show her how to do it? You have to, because you want to do that.
She knows how to do it. She explained it to me.
All right, well, come on then. How's yours look? Are y'all ready? Is it perfect? Oh my, that one is perfect. Stay right there. That was perfect. Let me see this meniscus. What you got? Oh, this is the perfect one from the very beginning, right? I want to see that mirror. I want to see that mirror. That was a good one. Okay, you see that? Now go down low. Now, students, let me tell y'all a little secret. You'll know when it's perfect. You know how do you know? How do you know it's perfect? Very accurate. How do you know? It's going to shine at you like a mirror. And what that shine is the reflection of the bottom hitting the line. That white line is going to make a beautiful mirror. Okay, let me see. You guys are above 50. Come here. Look. Look right here. You see 250? Yeah. Look, the long line. You see this long line? Now, you see this line? Look how far up you are. It's okay. Watch this. Oh, I don't have a long one. So, this is not long enough. So, no, you can't use your hand. Look. We're just going to be real patient. And we're going to just pour a very, very what? Small amount. Right? There. Now, let's see what we have. Get your air bubbles out of here. You got to do it again. You got to put, look, now you're going to pour a small amount. Do it again. You're not perfect yet. Okay, how many milliliters do you have in your graduate cylinder? 250. Good. What is the maximum volume that your cylinder will hold? 500 milliliters. Excellent. At this time, let's go to our experiment. Take your pencils up very quickly. Here's your pencils. Thank you, thank you. And let's look at it now. Okay, if you notice something, it says scientists, okay? Scientists use density to identify unknowns. Where is your metal?
Here.
What are the three characteristics you told me about metals? They were what? Shiny, beautiful, meaning what? Lustrous, and what else? Solid. Do they take up a lot of mass? If they're heavy. There's some that are light, like what? The soda can. Yeah, right? Aluminum. Okay, let's go. All right, look at your materials. Put a check by 500 ml graduate cylinder. We've used that. Put a check by 600 ml beaker. Come on, sweetheart. Put a check by you have your pencil? Oh, this is wrong.
Oh, I did it.
It's a shrub. All right, next thing. Let's go to the procedure. Note, if you have an electronic balance, use the 0 button. Now, let me tell y'all something. There are many, many balances in the lab, okay? What if you go somewhere and you're ready to use the balance and the lights go out? There's no electricity. The scientist still has to do their work. We still have to get our measurements. I am going to have you to come around me for just a second, and we're going to use a manual balance. And then, because we're fancy, we're going to come over here, and each of you will learn to use the digital balance. Now, here's the deal. The digital balance is an electronic balance. It will give you the mass of your unknown metal. Look in the materials list and put a check by unknown metal and put a check by balance. These are the things we're going to work with. And also, we've already used the what? Pipette. So put a check by it. And then what? Have we used water? Yes. Now, at this time, before we go to that balance, let's go down to number 5. Go down to number 5, and let's put that data in right now. It says, now go to 5, and I'm going to read very slowly here because I want everybody to know exactly why we're doing this. It says, using the data table below. You guys, this is where your volume information goes. Determine the displacement volume. Watch me up here. If I jump down in the pool like that, my mass will take up space and it will push the water around. All the water that goes around me will rise around me. In other words, I'll take up the space where the water was. There's a pool of water. Right now, imagine this pool of water. When I jumped in it, where that water was, I displaced it. I moved it, right? Where does it go? It would go around me and up and all over the pool. Inside of this cylinder, today your metal will go in there. When it goes in there, it's going to be put in, and it's going to move the water around, and that is called displacement. Now, on the board, I'm going to write, and I want you to look at your data chart while I'm on the board. We're all on number 5. On number 5, can you give me some kind of paper?
Yeah.
Get a running eraser, ladies. Because I will use my hand, and that looks just terrible. Now, on number 5, thank you, thank
There's a
you.
verse right above me.
Oh, if this was a snake, would it have bitten me? Thank you, thank you. Okay, you guys. Now, number 5 says, what does FV mean, guys? Read it for me, everybody. Look at your paper. Go to number 5. Final volume. Okay? What does IV mean? Look at it. Initial. When do we have an initial volume? In the beginning or at the end? At the what? Beginning or the end? Beginning. Beginning or the end? Beginning or the end? I heard someone say the end. When something is final, it's over. But when it start out, the beginning, okay? Initial, okay? So what is the symbol for initial volume? Very good. That means y'all are looking at your paper. Good. Thank you. Now, at this time, we are at the beginning. So I want you to record your data for the initial volume of water. Your initial volume should all be what, class? 250. Now, guess what? If we put something really heavy in here, will the water rise just really high or just a little if it's really heavy? Really, really high. Good, you got the concept. Okay, greater mass, when something is heavy, like if I jump in the pool, because I'm not that big, only a little water's going to go out, right? But what if we throw an elephant in the pool? What will the water do? So the greater the mass, what? The more volume will get what? Displaced, meaning it'll go around. Will this water come out of here when we put the unknown in? Maybe not, but where will it go? The water that was there before you put the metal, where will it go? That's what's up. You guys are so smart. Yes. Give yourself a hand. Because y'all are smart. I'm serious. I mean real hand. Come on now. Give me some hand. All right. I love it. All right. So our initial volume is 250. Now, everybody put an ML behind 250. Because you must, scientists always use its units. What does the unit represent? It is the actual, it's the volume, very good, but it represents the number, it's the unit, say it, Barbara. Some things are hard to explain. It just means it's, I know, isn't there something? Yeah, Barbara. What we're trying to say
how much
is,
it is, what it is.
it tells you what it is. Some things you can't say scientifically. What it's measuring. Oh,
What it's measuring.
I'm
That's
really
good.
smart in there.
And that's very,
That is good.
and that's very important, especially in
Yes.
school, because if teachers say, okay, the ounces to what? $250 or 250 meals or 250 cents.
Or
So you have to
grams.
fit those grams or whatever. So you have to fit those units to make your answer correct. If you don't have the units, it's not correct.
And when you get to high school and you take your STAR test, you're going to have to know those units when you write the answers in. All right, let's move on. Okay, so at this time, I want all of you to get ready for the next measuring device. Our next measuring device is the balance. Now, it says here, and I'm going to back up to number 1. It says zero the balance using the adjustment knob. Read at eye level. Weigh the object and record its mass. On item 1, you will record the mass of your unknown metal. Now, at this time, I want you to take your metal and come over here, and I'm going to show you how to use, put your seats back, put your seats back. Be careful in the laboratory when you get up, because if you have glassware on your table. Don't bring a seat with you. That's fine, Chris. I'm going to put this seat. Can you get that seat for me, young man? Thank you so much. Okay, now, come around. Some of y'all come on this side. Okay, a little bit of wait on it. There it is. Robert, I'm going to go in. There it is, there it is. It's still just a very on the way. You got it. Okay, now, always start at your lowest 10. Well, he weighs more than 10. Now where do I go? Okay, so does he weigh 10? We already knew he didn't weigh 10. Does he weigh 20 something? Nope, still above. Let's go on the table. Does he weigh 30? Does he weigh 40? Ah, he's between what? Look, he's between 30. Come around this side. He's between 30 and what? He's between 30 and 40. So what do y'all think? Okay, so yes, you guys are awesome. Okay, look. Now, you gonna get that? Now this, we gotta have so much, because we have numbers now. Now I want you to see what we would record. Almost the same here again, right there. Now, this is 30 grams, and this is 1. But each of those are tenths, like a dime. 10 dimes make a dollar. So that's 1 tenth, 2 tenths, 3 tenths. This is 31.3 grams. Look, 31.1.2.3. Got it? All right, let's go to the next one. Wait, one more thing. Never take him off the balance unless all the riders go back to 0. Because what happens is, no, that's a great question. What happens is, if you don't take him off of there, and the weights are down here, it starts to mess up the electronics, and the balance just loses its accuracy level, and then it becomes a ghetto balance. Okay, now you guys are gonna use, if anybody would like to use both, you can, but we're gonna all get our battery. Now, all you're gonna have to do over here is press the on button, do not lean on the table, show you one time. All y'all watch this.
Come over here, watch her over here.
In fact, let me get right where y'all can see. I'm gonna press the on, don't lean on the table, do not lean on it. Take your hands off the table when you're waiting. Press on, it's already ready. Put him on here. Oh my goodness, we are something else. 31.31. Now, is this balance more accurate than the other one? You know, you guys are awesome. This balance was 30, 1, 10, and this is what? Tenths. No. Listen, to the right of the decimal are your tenths. Listen to me. Listen. Ones. That was on the first, the smallest being. Tens. And what? Ten. T-E-N-T-H. That balance is what? 31.31. So what comes after tenths? Hundredths. Excellent. One thing about a scientist, your math skills become so much better when you understand the laboratory, because these are the measuring devices that makes your mathematics strong. So which balance is more accurate? The manual? Actually, they're both very accurate because both of them weigh 31.3. But which one gives us the greatest ability to weigh in the most, what's the word, Barbara? The most accurate level. You know what I'm saying? Like, okay, I asked this question. Which one weighs 2 places behind the decimal? The digital or the manual? Digital? No. Now, so 31.31. Got it? Now, at this time, turn your balances on and weigh your mass. Don't run in the lab. Okay. Now, before you weigh, you have to zero your balance. Make sure you zero it. Make sure it's zero. The sign is zero. Wait a minute. Be patient. Don't raise it up. Wait. Okay, go ahead and take it off now. Okay, students. No, it just weighs a lot. Okay, listen, sweethearts. Dear, I need your attention. I'm going to stand right here because I need you to look at me. On the balance. First, you turn it on. When the zero is stable, a little asterisk will come up. After that, put your mass on it. Now listen to me. Leave it on that balance. After you get your value, and you must do like real scientists do, go get your data sheet or remember it in your head because you're going to go write it down immediately, okay? But normally you would bring your data sheet with you. After you get that mass, do not pick it up. That's the same principle as taking the weight off of the manual balance. Return the riders back to zero, right? So when you get ready to pick this up, what should you do? Turn it off. And then what? Pick it up. 145.8. Remove your mass, and let's go determine the density. When you get ready to do this, you'll stand up again, not yet, just let me show you, and you will take your mass, look, watch me, and you will hold it because you're very patient, and you will just let it sit right there and slowly, and then it goes in. And if it gets away from you, it's okay, just be slow as you can. Don't throw it down in there because it will break the bottom. Now, once it goes down in there, look at that air bubble. Get those bubbles off of it. Let it, get your technique. Let it calm down. Let it settle down. Get those air bubbles out. Hold on. I haven't released it yet. And then, we know that the initial volume was 250. Then you come to the eye level, and you look at the bottom. What is your initial volume? Everybody, what is your initial volume? 445. the initial volume.
250.
Look on line 5.
Oh, 250.
250 what? 250 Ninja Turtles?
No.
No. 250 what? Milliliters. Okay, at this time, stand up, back up, and slowly release. Look at what you're doing. Don't pay attention to us. Look at your flask. Work together. Slowly release. Tilt it slow. Do you want it? Yeah, that's good. You can pull the flask back. You can tilt it slow. It's going. Okay, now let it go real slow. That's okay. That's okay. You're all right. Now get your air bubbles out. Uh-oh. It's okay. It's okay. When that happens, all you have to do is do this slow. And we're going to do them in this one. Okay. Knock them like that, Barbara. It's okay. Just give it a little tap. There you go. Make the air bubbles go up. You're going to read it for me. Okay, that's what it's supposed to do. What did it do? It pushed the water around, and it took up the space where the water was originally located.
What is this?
Okay, now, you're going to tell me. Okay, eye level. Okay, you're going to read it for me. Yes, I'll be right with you. Give me 1 second. Come on, girls. Go to eye level. And look. Okay, everybody, listen to me. Give me 3 claps, quick. Listen. In this flask, each line has what value? Okay, put your hand on 250. Now, go up to 300. And I want you to count each line between 250. Listen, tell me. Go to 250 and then go up to 300. Now tell me how many lines are in between.
9.
Okay, so now go to 250, so each line is a 10, right? So count. To what? 250, 260, 270, 280. No, these are not even that. Let's see. 250, 270. No, these are 5s, you guys. Because look, see this line in the middle? Watch. Let me come to each of you. Here.
Do you want to put this in?
Here, look. I'll show you something. Look. See this right here? That's 250, right? See this longer line? This is shorter than this. I'm coming to each of your tables. This line is shorter than this line. So between 250 and 300, this is 275. So this is what? 250, 55, 60, 65, 70, 75. You guys, they're each 5. In the liter, they're 10. Now I'm coming to each of you. Watch. Look, that's 250. This is 300. See how this one's longer than that one? This is your 275. So look, 250, 255, 60. See? I don't want you to do anything but read the Bible. I want you guys now to tell me what is your new volume. To what? Oh, no. This is a real important step. Hold up. Let me talk to each of y'all individually. Barb, roll out and mark at the 275 mark. Y'all did it again? Well, we're going to let y'all lower y'all's in with a string. That's okay. Let's just get that volume because we got to put it in there. Okay, let's go. Come on. Now, look. Watch me. Just watch me.
Okay, so let's do
Okay, this is 250, right? See how this line longer than those? This is 275. So this is 250, 55, 60, 65, 75, 80, 85, 90, 95, 300. Each of these are 5. So what is this? 250, 255, 260, 265, right? What you say? What's your body?
Where we put 265.
And then it goes back to short. Look, 280, 285, 290. Look, 295, and then long again. What? 300. Do y'all see that? Now listen to me. The bottom of that meniscus, this curve, where does it sit? If it sits right, give me another color, the green. Pass me that green. She'll give it to me. What if my metal was in this flask? Down here at the bottom, here's my unknown. And my water started out at 250, initial volume. But when that metal went in, it pushed that water around and it rose up. Say it got here. The bottom was here. That's 270. My initial volume was 250, and my final volume is 270. When I take the calculator and subtract, what is 5 from 7?
2.
They know it now. Okay, that's just fine. What's 5 from 7?
2.
So 20 milliliters is the volume that was pushed around. This is called the what? Displacement volume. At this time, you need to tell me what is your final volume. Final volume. We can do 2 what? 265. That's okay, but you know how to read it now. What about over here? What y'all got? Okay. Yes, and a lot of y'all metals look alike. And we know they do. Okay, now. Okay, good. So they all straight? Okay, now, all we're going to do now is go down to item, and we're about to wrap the lab up. I want you to go to number 6, and I want you to turn your paper on the back. And we're going to plug into the formula the mass that we got from line 1. Go to the back of your paper. Markers. Go to the back of your paper and write down D equals M over V. Boy, I couldn't make it without you ladies. Okay, ready? Put D, density is equal to mass over volume. Write that now on the back. Write the formula. And below that, can I erase my volumes? Because y'all got y'all data, right? Okay, look. Now, below that, you're going to say, what is the M value, the mass in grams that you have on the front of the paper? Flip it over and look at how much your metal weighs. Go to number 1 and tell me how much your metal weighs. What? Okay, turn it back over and put that in the numerator. Go put that in your thing. Whatever yours weighed, all of them were different. They all were different. That's going to be the difference, is that. Okay, they all, whatever that amount is, plug it into this formula. This is how you use formulas to identify substances. Okay, listen, students.